In this video, we are going to study about the second method of producing ultrasonic waves like piezoelectric effect. Okay, let us see what is a piezoelectric effect. When a crystal like quartz, Rochelli salt, tourmaline crystal, etc., whenever they undergo mechanical deformation, that is a stretching or compression along the mechanical axis, then an electrical potential difference is generated, that is produced along the electric axis perpendicular to the mechanical axis. Okay. So whenever we are taking a crystal like quartz, suppose it's an example of quartz, it undergoes mechanical deformation that becomes a stretching or compression of the crystal along the mechanical axis, and electrical potential difference is produced along the electrical axis perpendicular to mechanical axis. That is, we are applying the stress according to the mechanical axis, the potential difference will generate perpendicular to that mechanical axis, that means into the electrical axis. See here what is happening. Whenever the deformation axis according to mechanical axis, the electrical potential difference will generate perpendicular to it, that is, it is the electric axis. Okay, so converse of this effect is also possible, that is inverse piezoelectric effect. So let us see what is inverse piezoelectric method. When an alternating potential difference is applied along the electrical axis, so the crystal will be set into elastic vibrations along the mechanical axis. So inverse we are applying, that means whenever we are producing the potential difference, that means whenever we are alternating the potential difference along the electrical axis, or that applied along the electrical axis, the crystal will be set into elastic vibrations, and the mechanical axis, according to the mechanical axis, the elastic vibrations will be produced. So if the frequency of the applied field coincide with the natural frequency of the crystal, so in magnetostriction method we are using a rod, the natural frequency of rod will matches with the applied frequency, then the ultrasonics will produce. Here whenever the applied frequency coincide with the natural frequency of the crystal, because here we are using the crystal, so it vibrates with large amplitude producing ultrasonic waves, so having large vibrations. This phenomena is utilized for the production of ultrasonic waves. Now the experiment set up for the production of ultrasonic waves using a piezoelectric generator. Let us see how it will be. Okay, see, that is how the construction will be. The quartz crystal between two metal plates that is connected to the collector. Okay, that's connected to the collector and base of a transistor. The collector is also connected to the LC circuit, and high tension source shunted through a bypass capacitor. Okay, so this is the high tension circuit which we are using, and this is a bypass capacitor. Okay, we are using. Next, the capacity of the variable capacitor is adjusted. Here also the capacitor will vary. So this is the variable capacitor. The symbol indicates that the capacitor is variable. The capacity of the variable capacitor is adjusted so that the frequency of oscillating circuits, that is equal to the natural frequency of the crystal. Okay, so by adjusting this capacitor we can get the frequency match, that is the frequency of oscillating circuits that equals to the natural frequency of the crystal. So that Rg, this resistor, this is a necessary biasing for the base and emitter circuit. This is a necessary for this circuit. Okay, we can get this by varying this. Whenever the applied frequencies matches with the natural frequency of the rod, then only we can get the ultrasonic waves. So now let us see how the working of the inverse piezoelectric method. When the circuit starts functioning slowly, an alternating potential difference is built across the crystal, that is a quartz crystal, which sets the crystal into the vibrations. Okay, so it means slowly we are giving the potential difference. So by varying the capacity of the capacitor C at a particular stage of the frequency of the alternating potential across the crystal that coincide with the natural frequency of the quartz crystal which we are using for this. So it is setting up to produce ultrasonic waves. So whenever the capacities varies, the capacitance of capacitor will vary automatically. At a particular stage, the frequency of alternating potential across a crystal that will coincide, that will matches the frequency of the natural frequency of the crystal, then the production of ultrasonic waves will be possible. So this indicates by milliammeter by showing a maximum current. The natural frequency of the quartz crystal of thickness T is given by F equals to n by 2T into root of y by rho, where y is the Young's modulus and rho is the density. So by indicating according to the milliammeter we are using here, so by noticing that the maximum current in the milliammeter, we can find that the frequency matches and we get the ultrasonic waves also. Okay.